Hi Kevin. I decided to make a tutorial to show you how to blast because it's pretty straightforward, and then also I'm not going to be in Monday, so I figured this would be a more straightforward way for you to learn. Okay, so by now you probably already have your list of target proteins in the zebrafish, and so hopefully you have a list of the epitopes. If you don't have a list of the epitopes, I can show you really quickly how you can get to them. So for example, one of the proteins that we're interested in is AKT, I believe, right? And so if you go to any of the antibody companies like Santa Cruz Biotechnology and you search for their antibody AKT, oftentimes they will tell you exactly where um, the epitope that they use to generate the antibody. So for example, here, right, they're showing that they generated an epitope against amino acids 443 and 479 of the, near the C terminus of the human AKT origin. So in that case, what you want to determine is how similar that stretch of amino acid is between zebrafish and humans. So you can go to the NCBI protein page, and if you type in AKT, the name of the protein, and search, you should be able to pull up, let's see here. We can select, they were using Homo sapiens, which is humans. So if you click here on Homo sapiens, it should limit AKT. Actually, we might need to search for AKT1. Let's see what happens. Okay, so let's try this again. Let's try, we're just going to add the 1 to this search string here, and it should find out maybe. Okay, great. So there's AKT1. So it's a 480 amino acid protein, and the epitope was generated against the last 443 to 479 amino acids. So what we can do is just scroll down the page, and these are the last. Let's see. This is the numbering system for the amino acids. So this L right here is number 421, and these are arranged in groups of 10. So this is 421. Let me get my pointer here. Yeah. So this is 421. This is 431 here. 441, 451, 461, 471. Believe that's right. And they said that there was a total of 480 amino acids. Yep, that makes sense. And the from 443 to 479. So we'll just grab 443, which would be right here, starting at the T, right, until the last stretch here. So now we've got the epitope that they use to generate the antibody. You can copy that. And then we're going to go to another page. Uh, we're going to go to the BLAST page. And so to go to BLAST, this is the web address for BLAST. Okay. And what you'll do is we're going to look at the zebrafish genome. So you're going to click on zebrafish. And the type of protein we're going to search is not a nucleotide blast, not a blast in. The blast in means searching for a nucleotide. We're going to search for the protein. So you can click blast P and you can copy and paste that stretch of amino acids in there. And then hit blast and it should pull that up. Now for the, this is how, let's see, and it should keep working. In a few seconds we'll see the results. Okay, so these are the results, and so what it does is it looks through the zebrafish genome and it finds the top hits, and so this is a list of the hits that it found. And so some of these are actual confirmed proteins, some of them are predicted proteins. For our purposes, it's okay, but what's important to know is that they rank them from the highest likelihood to the lowest. And so here is a list below of the proteins that it found. And so the protein that had the highest similarity between the ones that we looked for is this protein here, which is called in zebrafish RAC alpha serine threonine protein kinase. Same name, same protein. So if you click here, this will take you to the alignment, and this is the actual alignment. And so the query, that's the sequence that we pasted, and then the subject is what what it found. And so you can see that this protein is highly similar between humans and zebrafish. And so what you'd want to do is copy this information here and keep this in a chart. I would say copy from here. Matter of fact, you can just click this button. I think you can download it. Okay. And so that lets us know how similar the antibody is and gives us a feel for whether or not it should work. Now, if you're looking at a phosphorus-specific protein, you should do the same thing, but then you have to go and figure out which amino acids being phosphorylated. So we'll try that in another video.